In this video, I'm going to solve this second order constant coefficient homogeneous differential equation, and the equation is y double prime plus 3y prime minus 4y is equal to 0 with initial conditions y of 0 equal to 1 and y prime of 0 is equal to 6. And of course, we are making the assumption that y is a function of t. Y is equal to y of t. This type of differential equation has the general structure, which is a y double prime plus b y prime plus cy is equal to 0. And our assumption is that the solution will have this form: y of t is equal to e to the power r, some number r, real number, times t. Of course, r actually could be a complex number too. So, but in this particular case, we are going to be dealing with real numbers. Now, let's go ahead and solve this problem. So, my assumption is that y of t is equal to e to the power rt. So, y prime is going to be r times e to the power rt, and y double prime is going to be r square times e to the power rt. If I plug in all these three values into this equation, I get r square e to the power rt plus 3r times e to the power rt minus 4 e to the power rt is equal to 0. And if I factor out e to the power rt, I'm going to have r square plus 3r minus 4 is equal to 0. And this, by the way, is not equal to 0 because this is an exponential function. So it's never 0. But in that case, this has to be 0, which is r square plus 3r minus 4 is equal to 0. Now, if I factor it, it's going to be r square plus 4r minus r minus 4 is equal to 0. Or if I factor out r, I'm going to get r plus 4. If I factor out negative 1, I'm going to get r plus 4 is equal to 0. Or r plus 4 times r minus 1 is equal to 0. So this is going to give me r is equal to negative 4 and r is equal to 1. So my y1 is going to be e to the power t, let's call it, and my y2 is going to be e to the power negative 4t. Now my general solution, or family of solutions for this equation is going to be y of t is equal to c1 y1 plus c2 y2, that is going to be c1 e to the power t plus c2 e to the power negative 4t. And now we could use the initial conditions. Y of 0 is equal to 1, y prime of 0 is equal to 6. So let's go ahead and find the y prime of t first. Y prime of t is going to be c1 e to the power t plus, actually is going to be minus 4 c2 e to the power negative 4t. Now I could apply the initial conditions. So if I apply the first condition, y of 0 is equal to 1, I'm going to get c1 plus c2 is equal to 1, because e to the power 0 is equal to 1, e to the power 0 is equal to 1. And similarly, from the second equation, y prime of 0 is equal to 6. So that is going to be c1 minus 4 c2. And that is going to be equal to 6. Now it's pretty easy. So c1 is equal to 1 minus c2. So I'm just going to plug it in here. 1 minus c2 minus 4 c2 is equal to 6. or 1 minus negative 1 minus 5 C2 is equal to 6, or C2 is equal to negative 1. So that tells me C1 is going to be just 1. Okay, because actually 2, sorry. C1 is equal to 2 because C2 is equal to negative 1. So now I can just go ahead and plug in these values right here. There's gonna, not there actually, right here. So that's gonna give me y of t is equal to C1, which is 2 e to the power t, plus C2, which is negative 1, is gonna be negative e to the power negative 4 t. So that's gonna be your solution. So this is the solution to this equation. I hope that this discussion was helpful. Thank you very much.